Okay, so we got a question here. It says the diagram shows a particle of 0.5 kg is placed on a rough inclined plane with an angle of alpha, and they're given the value of sine alpha as well as 5 over 13. And this particle is held in limiting equilibrium where it's on the point of moving upwards with the help of a horizontal force of 8 newtons. So we need to show that the coefficient of friction is equal to 0.71, and also they want you to find or determine whether the particle will move if the force of 8 newton is removed. So let me first mark the forces on this acting on this particle. So here's my inclined plane. So first thing, the weight should act downwards, which is 0.5 g. In this case it's going to be 5 newtons. The reason is because they want us to take g as 10, but I'm going to resolve this into perpendicular directions. One is, this is going to be mg cos alpha. So in this case it's going to be mg is going to be 5 newtons, so it's going to be 5 cos alpha. So let me take this as mg cos alpha, whereas mg is 5, and this way it's going to be mg sine alpha. And since it's in contact with the plane, there should be a normal reaction R. And in addition to this, there is the 8 newtons acting horizontally. If you resolve this force is acting this way. So if you resolve it, it's going to be acting this way and this way. So let me take this as 8 cos alpha and this as 8 sine alpha. Since the particle is on the point of moving up the plane, friction should act this way, which is mu r. So here are the forces acting on the particle. So now we can figure out, we can apply F equals ma first. So let me apply F equals ma perpendicular plane. So you got R minus mg is 5, so 5 cos alpha minus 8 sine alpha is equal to 0. So R is going to be 5 cos alpha plus 8 sine alpha. Now sine alpha is equal to 5 over 13. So if you draw a right angle triangle, this should be 5, this should be 13. So using Pythagoras theorem, we can say this should be 12. So cos alpha should be 12 by 13. So R is going to be 5 times 12 by 13 plus 8 times 5 by 13. So our R will be 60 plus 40. That's going to be 100 over 13 newtons. Right, so that's my R. And next I'm going to apply F equals ma in this direction. So you can see we got F equals ma. So 8 cos alpha minus mu r minus 5 sine alpha is equal to 0. So mu times r is equal to 8 cos alpha minus 5 sine alpha. So R is 100 over 13, so we can say that's going to be 100 over 13 mu is equal to 8 into 12 by 13 minus 5 times sine alpha is 5 over 13. So basically 13s will cancel off, and then you got 100 mu is equal to 96 minus 25. So 100 mu is equal to 71. So this means mu is 0.71. So that is the first part of the question, where we need to show that mu is 0.71. Now you can say that this particle was held in equilibrium and it was also on the point of moving upwards because of this 8 newtons. Now what happens if the 8 newtons is removed? So let's see what happens. So once again, R and this is mg sine alpha and this is mg cos alpha. These three forces will be still acting. Now that there is no 8 newtons to hold this, object, so friction should act this way in order to prevent it from sliding down. So since we know the value of mu, in this case if I apply F equals to ma, my R will be mg cos alpha. So my R is going to be 12 into 5 over 13, that is 60 by 13 newtons. And mg sine alpha is going to be 5 times 5 by 13, which is only 25 by 13. So in this case, the maximum value of friction, so friction's maximum should be equal to mu r. So this is 0.71 into 60 over 13. Let's check how much is this. That's going to be 3.276 newtons. So the maximum value that friction can have is 3.276 newtons, but the weight component acting down, which is mg sine alpha, is 25 over 13, that is only 1.92. So that means friction is sufficient to prevent the particle, which is the from sliding down. This is greater than 15 by 13 newtons. That's the reason. So 3.276 is sufficient enough. So what happens is friction will become equal to 25 by 13 newtons and keep the particle in equilibrium. Hope you understood.